our Macmillan Space Center and to Ground Station Canada. My name is Najat, and today we're going to be talking about what a day in space looks like, specifically for the people that are on the ISS, the International Space Station. Now, quick, simple question, who here would like to go to space? If you were offered a ticket to go to the International Space Station. Okay, I see a lot of hands, that's great. Me too, 100%. Now, what do we think is the biggest difference between a day here on Earth and a day up in space? Yes, my friend?
Definitely zero gravity and probably
100%, yeah. So you're saying zero gravity, so no gravity, right? Hands up if we agree. Hands up if zero gravity. Okay, hands up, yes gravity. Okay. Well, it makes sense that we say zero gravity, right? So we see an image here of Chris floating in space, and at least for me, I was like, he's floating because there's no gravity. But Chris is not floating, rather he's falling constantly at the same speed of Earth. To put this in perspective, I want you guys to imagine for a second, if you were on an airplane, no seats, no seatbelt. You're just standing there. And all of a sudden, that airplane takes a deep dive down. What do you think would happen for a second? Right? I hear some people say floating, some people falling.
it would be like zero.
It would, 100%. So do you see what's happening here? They're floating. So that's basically what's happening to our astronauts here, is they start to experience things, something called microgravity, right? And that's what gives us the effect of them floating. And that's why someone assumes that they're floating because there's no gravity, but there is gravity. It's just falling. Here on Earth, we probably experienced microgravity, but didn't realize it. If anyone here has been on the wooden roller coaster, or the elevator, or any ride that takes a deep dive down, right? It takes a deep dive down, and then all of a sudden you feel your body kind of levitate up, right? As if you're floating. But what's actually happening here is you're just falling. Yeah. Yeah, you can see that as well, 100%. Yeah, 100%. That makes so much sense. Now, how do we get things to fall? Well, if you think about it, if we were to launch anything from the North Pole, the faster we launch it, the further away from Earth it keeps falling, right? The slower we launch it, it falls back towards Earth. So if we wanted things to fall, but keep missing Earth as they fall, and they give us what we call an orbit, we need to launch them at a speed of 28,000 kilometers per hour to break the Earth's gravitational field. And what happens here is these objects, as they fall, instead of falling back towards Earth because of their speed, they will continue doing these orbits thanks to the gravitational field of Earth. That's exactly what the ISS is doing right now. It is orbiting Earth 16 times per day as we speak, which is really, really fascinating. Now this right here is the Falcon 9 rocket, one of the few ways that we send people to the International Space Station.
Liftoff confirmed. Antares VSS Gene Cernan now bound for the International Space Station.
Once you're up in space, you'll spend the rest of your days floating, or like we said, falling. Now when we look at our astronauts here, what do we notice with their faces? They look a bit different. Can you point out what they look like maybe?
No wrinkles.
No wrinkles, yeah, that's one of the benefits of going up into space. But what's happening here is when you look at their faces, notice how they're a bit red and puffy. And what's happening here, well, what happens here on Earth, we know that gravity pulls us down. When you jump, gravity is the very thing that pulls you down, which means all of the liquids in your body is also pulled down by gravity towards our legs and our feet. But when you're up in space, everything is floating, including the liquids in your body, which means that puts a lot of pressure on your face and also your eyes. And one of the things astronauts experience when they come back here on Earth, when gravity hits them, is vision loss, right? For 6 months to a year, their vision is terrible. And that's because there's been a lot of built-up pressure around their face. And they actually have a name for this. It's called the puffy face syndrome. And astronauts will experience this the first couple of days to a week when they're up in space. Eventually, their body kind of gets used to it and it dies down, but it's one of the effects of microgravity. All right. Now, if you were to go to space, you'd spend most of your time in this little capsule here, called your bedroom. And when it's time to go to sleep, you're going to open it up. And it kind of gives me a hard time, so just bear with me for a second. There you go. So you open it up, and obviously it'd be easier up in space. And when it's time to go to sleep, you kind of just float to your little bed that's right here. And if anyone's been camping, like you zip yourself up, similar kind of. And you float there, you zip yourself up, and you gotta Velcro yourself up as well. When we look at this image here, Chris sleeping, notice how his head is Velcroed, which is not necessary, but why do you think he has his head Velcroed? Any guesses? Yes. Do you have any guesses? All right, so what's happening here is Chris snores. And when you're up in space, the first thing you'll realize, the biggest difference, is that you're really, really lightweight, right? Which means that if you're releasing things out of your body, that's enough force to kind of get you moving, right? So your head would kind of be moving back and forth as you're sleeping, which means that if you wake up, you're gonna be like, oh, something's a bit, different or sore. So if you snore, you gotta Velcro your head back as you're sleeping, one of the requirements. But if you don't, then that's good for you, you're just sleeping. And then the other things we notice here is our space toilet. Now, one of the exciting things that you're gonna have to do if you were to ever go to space is to potty train all over again. And one of the trainings literally requires having a camera inside of the toilet and then a small TV right in front of you broadcasting everything live. And what's happening here is you basically have to get used to the positioning of your legs, your thighs, your back, your toes, that gives you the nice clean drop. And that is going to be the position that you'll be using throughout the whole time while you're up in space. So that's one of the training that you have to go through. And then we've got these little locks here, if we can see it. And also right here, I have my laser pointer, that'll be a bit more, actually don't have it. Just on the sides, they look like handles, but they just kind of go over your thighs when you're doing your thing. And just like we said earlier, if you're lightweight and you're releasing things out of your body, that could be enough force to kind of get you moving. So you gotta make sure it's a nice clean process. So these things are kind of like a seatbelt when you're using the toilet. And then we've got something that looks like this here. Any guesses what this might be? Yes? 100%, yeah. Very close, very, very close. Yeah. You guys are getting close. So this right here, do you want to do one more guess? Yeah. Okay, yeah, exactly. There you go. So this is a urine tube collector. So it collects your urine, of course. And the cool thing is, I don't know why this excites me very much, but each astronaut gets their very own custom cup. And then whenever it's time to, pee, they will attach that cup to the hose, and then they will do their thing, and then they have a little vacuum that just sucks all the pee away and then throws it in a little box. Now, what do we think happens to the pee up in space? What do we do with it? Any guesses? Yes? 100%, yeah. So all of that urine that was in the little box that we're talking about is later recycled and reused all over again for drinking, eating, cleaning yourself, planting, experiments, and all of that. And the other cool thing is also sweat. We're gonna talk later about how astronauts exercise. And here on Earth, when we sweat, it kind of just falls down our bodies, but then the sweats in space kind of become like little bubble particles that float into these ventilations. That's taken, and then it's also recycled as well. Now the really cool thing is the tools and technologies that recycle all of these bodily functions and end up turning the water that's recycled cleaner than the waters we drink here, the sink waters. So It's pretty fascinating, and it's also really wholesome knowing that we use the same
okay
tools and
lah, Google ko
technologies
sila.
from the International Space Station to different countries that have not clean water. And we are now drinking clean water all because of the International Space Station, which is really, really cool. Now, recently, they've been thinking or finding ways to recycle things like feces as well. And that's because, what do we know about water? Water in space is luxury. All of the water that they bring from Earth comes in these little packets, and that's all the water that they have. Right? We're not always launching materials like water and food to them whenever they need it. We give them the right amount, and that's basically what they're living for while they're up there. And here you can tell that showering is going to look something like this when you're up in space. Obviously, there's no shower in space. You can almost imagine how that would be a disaster. And if you have no hair, it's much easier for you. Just like this. Of course, now eating in space is definitely different. We know that food, of course, expires, and we need to change the shelf life from a couple of days, weeks, to months, or even years. And we do that by dehydrating the food, and then we shove them in these packages. And later, what happens is, when it's time to eat, they will just grab this package, and then they will have this machine that generates hot or cold water, and then they just put their food in that machine, and then it just generates that water. They give it a good mix, they open it up and eat it, just like that. Now, one of the experiments that the International Space Station is doing is trying to find ways to plant in space, right? And that's because they want to eat more produce. Now, the International Space Station has successfully planted 3 kinds of lettuces, so they're munching on some, fresh lettuce up there. And they're also trying to find the effects of microgravity, which we'll be talking about right now. Now, one of the experiments that they do is trying to find the effects of microgravity in planting, right? And also the effects of microgravity on our bodies. And that is because recently we've been hearing a lot of space agencies talking about deep space missions to Mars, right? Mars has been a hot topic in astronomy. And if we were ever to send anyone to Mars, right, we can't just hop in a rocket and fly into Mars, right? That would be kind of a big risk, because as far as we know, that Mars is far away. Going to Mars can take up to 6 to 7 months. Coming back can take longer, and that's because of the way that our planets orbit, right? They can get a bit closer, a bit further away from each other. If anyone were to get sick, and we are not really confident with the long-term effects of microgravity, coming back would be a really big risk. So that's kind of what they're doing here, is they're taking advantage of something really close, like the International Space Station, and making sure that we're building the confidence before we send anyone to Mars, which is very exciting. Now, one of the other jobs that astronauts have to do is spacewalks, which means that they have to maintain the International Space Station itself. When we're sending people to space, we're not only sending astronauts, but we're sending people like doctors, researchers, scientists, of course, and also engineers, because someone has to maintain the International Space Station. So this right here is a spacewalk, and spacewalks can take up to 12 hours. Putting the astronaut into their spacesuit takes the whole team. Maneuvering them to the door, staying in contact while they're up there in space, right, takes the whole team. Now, if you were to do a spacewalk, you would probably most likely be using the Canadarm. So if you look up right here, this is Canadarm 2, or Canadarm 2, and that is one of the Canadarms that are attached to the International Space Station, and our astronauts use it to maneuver around and fix things. Now, if you were to do a spacewalk and you need to use the bathroom, you literally can't. That means our astronaut right here is wearing a diaper, right? And NASA actually is offering people, not offering, NASA's actually taking ideas from people. So if you have a solution for this issue, right, they will be taking it, and then you will be the person that solved the diaper dilemma in space, because astronauts are fed up with wearing diapers as they do the International Space Station spacewalks. Now, exercising, of course, or just staying active here is really important here on Earth, but it's far more important in space. And that's because when you're up in space, all of the movement that you're doing for the next 7 to 6 to 1 year months to a year does not count. Which means that when you come back here on Earth and gravity hits you instantly, you are going to be very weak, very shaky, very wobbly. Now what's happening is, imagine if you were to lay on your bed for a whole year, no movement at all, and you're like, I think it's time to get up. Right? You're not. It's not going to be the same as you were last year. So that's why it's really important for astronauts to exercise at least 2 hours per day. But why are they exercising if it doesn't count? Well, if you look right here, notice that there's straps pulling our astronauts down the same way gravity pulls us down. We are constantly fighting gravity here. As I'm walking past or down the stage right here, I'm fighting gravity. But we're used to it, so we don't really feel it. But once you're up in space, you're definitely going to feel it, and you need something that pulls you down. Now you have something to fight, now you're active, right? You got your blood flowing, your heart racing, and when you're back here on Earth, your journey to going back into normal will be less stressful. Great. Other than that, our astronauts, of course, love to have fun. We've only sent around 750 people to the International Space Station. If you're going to go there, definitely make the best out of it. And playing with water is really fun in space. Alright, and this is our current International Space Station crew members. And as we speak, they are orbiting our lovely planet 16 times per day. And the really cool thing is you can actually see the International Space Station with your naked eye. A couple weeks ago, when it was surprisingly clear here, I think I was walking out of my car, and then I was like, oh, it's clear, and I see a little star, and I was like, oh, I think this is Jupiter. I know what Jupiter looks like. But then Jupiter starts moving a bit too fast, and I was like, that is not Jupiter. So I pull out my phone, that helps me identify which star I'm looking at, and when I pointed it at the star, it showed the International Space Station on my phone moving, following that object. I was like, cool, that's the International Space Station. And it's really fascinating because you look at it and it looks like a star, and you're like, there's people in there, and they're doing all the crazy things that we talked about. And the very neat thing is you could actually stalk the International Space Station yourself. You could download apps called the ISS Tracker, and you could track the International Space Station. Or you could kind of pull out a schedule, and it'll tell you exactly when and where the International Space Station will be above you, depending on where you live. And it's really, really fascinating to look at. But other than that, I hope we all have somewhat of an understanding of what it's like living in a microgravity environment, and kind of acknowledge the hard work of all these astronauts and how they not only help us understand things in our universe, but also here in our lovely home, Earth. But other than that, do we have any questions?